Good morning, everybody. I hope you're well and doing fine, and I've been praying for you and for your families, and God bless you today as we get going here on a brand new Monday morning. We're going to start today talking about logarithms, and logarithms might be completely new to the majority of you. Logarithms are really used to show inverses for exponents. So we have this whole new type of notation for us to think about regarding exponents and how to solve problems with them. And we're going to look at an application before the end of the time that we have this morning. But a logarithm, here's our basic exponential equation, okay? A number to a power equals something. Okay, so whatever, we've been doing those type of things. Logarithms take that and shuffle the whole thing around. Okay, this is logarithm log base b, here's our base, of x equals y, equals the exponent. So really, a logarithm is a way of asking you b to the what power equals x. So when you're doing problems based on that, it would be the same as writing b to the y power equals, and then you'd be trying to find out how much x equals. So let's look at an example that has some numbers in it. So 3 to the second power equals 9 is the same as log base 3 of 9 equals 2. Log base 3 of 9 equals 2, because 3 to the second power equals 9. And this would be in logarithmic form. So this will be pretty interesting for us to figure out how to show graphs of that. I'm going to have to get creative as far as your quiz goes, either with the information or having you email me some parts of this, because I need to know that you can get the format right. Okay? All right, so let's look at some others. First step is that you need to get familiar with and practice putting it into that form. So let's practice a little bit. We have all of these equations that they're all solved out. We're just practicing putting this into logarithmic form. So each one of them is going to have a base, log base something of something equals something. So take a minute, you might want to pause and just write these things down and see if you can write it in logarithmic form. Okay, so since you've paused now, let's go over this. Log base 5 of 125 equals log base 5 of 125 equals 3. Log, our base is 1/2, log base 1/2 of 1/32 equals 5. Because 1/2 to the 5th power equals 1/32. Log base 2 of 16 equals 4. And log base 7 of 49 equals 2. So first of all, getting used to the logarithmic form. Now they are inverses. It does lend itself to the idea of inverses. Okay, and that's what it's going to be useful to us down the road here. Okay, now if you're supposed to evaluate this by hand, and this is a thing, this would be something that on a college entrance exam or an SAT, they could give you a problem like this and tell you to just evaluate it, find the answer. There are some that lend themselves to really needing to be calculator work, and before you ask, if we'll notice on here, there's a log button, but it doesn't allow you to change the bases. This is something special. since it doesn't allow us to change the bases, we would have to trick the calculator, and we're not ready for that yet. We have to understand what logarithms are before I show you how to trick the calculator and giving you answers. And the trick is actually longer and more complex and involved than actually just knowing what this means and finding the answer. So super important for you not to just be a button pusher. All right, so this log button, if you push log of 32, it's not going to give you log base 2 of 32. Okay, if I push log of 32, let me just clear this off. Log of 32. Notice it doesn't say log base 2. There's no way to make your calculator do that. That's not our answer, because what we do is we rewrite this 2 to a certain power equals 32. We need to figure out what number that is. Okay, if we write it with like bases, that's going to be our strategy. That would always be your strategy to look for first in logarithms, because many of them can be solved just in terms of like bases, especially the simpler ones, and those are the ones that you would be expected to be able to do calculator free when you get possibly with a college placement exam or something like that. So 32, if you had broken it down by factoring, would really be 2 to the 5th power. 2 times 2 times 2 times 2 times 2 gives you 32. So since we have 2 to the x power and we have 2 to the 5th power, you're just having 2 to the same power. That means that this right here, x equals 5. Hopefully that makes sense. So the way your answer would look would be log base 2 of 32 equals 5. Your answer here would just be a 5. Okay, so that would be your answer. It's not going to let me write it, but that's okay. I can copy it and paste it. We'll take that. So here's our log base 32 of 5. Log base 2 of 32 equals 5. All right, let's take a look at some other ones, because this one's nice and simple, because this one is actually just a power of this base. So that works out very, very nice and easily. These are the simplest type. But we're going to take a look at some that are not quite that simple, because some of them have more steps to do to be able to figure out what's happening here. Okay, so let's figure out what's happening on these problems. So log base 8 of 32. That means 8 to a certain power equals 32. But there's not a whole number that's going to do that for us. Just even 8 squared is 64. So we think maybe we're stuck, but no, we're not, because each one of these can break down into 2 to a power. Okay, now our base is actually 8 here, which is fine, but you want to also think about breaking it down and thinking about its factored form. So 8 is 2 times 2 times 2, so 2 to the 3rd. 32 is 2 times 2 times 2 times 2 times 2, so 2 to the 5th. So here we have this. 2 to the 3rd power, which is 8, to the x power equals 2 to the 5th power. If you remember your power to a power rule, it applies even when you have an exponent. So 2 to the 3rd to the x power is 2 to the 3x power. Now we have like bases. And if you have like bases and the two things are equal, that means that these exponents have to also be equal. So 3x has to equal 5. So x equals 5/3. That's our answer. So what that's telling us is that 8 to the 5/3 power equals 32. You could either check that with your knowledge of index and exponent, or you could use your calculator to check it if you use your caret button. So here's the one trick that you can use for your caret button. You could say, I want to check, so I'm going to check and see if 8 to the 5/3 power. Watch out for parentheses here, because it does make a difference. Equals 32, and it does check out. So while we don't have a change of base key on there, we can do things to check your answer once you're done. So these steps are important. When we do quizzes, tests, I'm going to try to figure out some way to have you show me a specific step. So do practice doing these in steps. Okay, don't do it guess and check, because we're going to try and make it so that we can test and quiz to see if you can do these steps, because non-calculator method is going to possibly be important to you, depending on what your college's entrance exam or placement exam looks like. All right, so let's do this one. 4 to a certain power equals 32. Once again, this can be 2 squared. This could be a 2 to the 5th power. Power to a power multiplies exponents. This one very similar to the other one. 2x equals 5. And finally, x equals 5/2, and that's your final answer. Okay. Boy, this is being stubborn. There we go. All right, this one, 5 to a certain power equals 125. This one's kind of easier because 5 to the 3rd, 5 times 5, 25 times 5 is 125. So x just equals 3 without having to do very much for this. But you do need to see that fractions are a possibility. But you're always trying to break it down into a simple base for these things. Okay, 64, oh, fractions. Fractions are not necessarily horrible. So you can look at this. We do need to write it as 64 to a certain power equals 1 over 32. We're going to do this in steps. 64. Okay, 64 is just one more power up from here. So that's 2 to the 6th power. This is now 1 over 2 to the 5th power. So let's think about how these things can reconcile. This is still 2 to the 6x. But if you remember how powers in the denominator work, this is really 2 to the negative 5th power. Okay? Because this tells you to make the exponent positive, it's the reciprocal, the definition of negative exponents, just to remind you of that. So same bases, 6x equals negative 5, and so negative 5/6 being your final answer on that one. Okay, so once again, you could go back and you could check. I'll do this last one just in case you were uncertain, did I get the right answer at the end? But you have to do it in terms of the exponential form. 64 negative 5/6 power. And that gives you that. Oh no, I still don't know. Yes, you do, because you can do your math frac trick. Turn it into a fraction. 1/32, and it did work out. Okay, so there we're getting there. Okay. So you have the skills now to evaluate manually the ones that are nice, convenient powers. And we do have another issue that we need to talk about is, you know how sometimes, like when we had a square root and the index that was hiding was a 2, when you don't have a base written here, there's actually a hidden base, and that hidden base is 10. So when you don't have a base, it looks like you don't. This is really a log base 10. So log base 10 of 1,000, 10 to a certain power equals 1,000. So x would equal 3. Okay, because 10 to the 3rd power equals 1,000. Okay. Now here's an example of what this is used for. You've often we hear in the news about earthquakes in various different places, and they say it's like a 8.3 magnitude earthquake or a 2.1 magnitude earthquake. And a lot of times people are like, okay, great, so we have a 7 and you have a 5, and it doesn't really sound like that much of a difference as far as how strong that earthquake is. But the Richter scale is designed based on powers of 10. Okay, so those numbers that you have, we're going to call M, and the intensity, in other words, how much shaking is happening because of that earthquake, is I. So how intense that is based off of a number on the Richter scale. And so this formula, log, it's base 10, log base 10 of intensity for the first one divided by the intensity for the second one equals the number on the Richter scale for the first one minus the number on the Richter scale for the second one. And then we can find out how much stronger one is than another. So I've got a couple of word problems here that were things that were actually happening a couple years ago. Okay, well, this one's more than a couple years ago. This is 2004, 2005, but I have a much more recent ones that you'll remember very shortly. But there was a big earthquake in 2004. I had a 9.3 rating in Sumatra. In Sumatra. And in 2005, there was another one of 8.7 magnitude. How many times stronger was the first earthquake? So when we look at this, the intensity ratio equals the magnitude of the first one minus the magnitude of the second one. The magnitude of the first one was 9.3, and the second one was 8.7. So we do that subtraction, and it shows at 0.6. And that doesn't sound like too terribly much, but remember, we're looking for how many times stronger. So since we're looking at how many times stronger, what we need to do is calculate how much I1 over I2 equals. So we're looking for 10 to the 0.6 power. Okay, 10 to the 0.6 power is going to equal I1 over I2, just like our setup that we did before. Because you've got your base 10 to this power, base to the exponent power equals this. And this is going to give us how many times stronger the one earthquake was than the other. 10 to the 0.6 power. So you could theoretically attempt to do that by hand, but let's do this way. 10 to the 0.6 power. It gives us about 4. So in this case, there was about 4 times much more shaking, 4 times much more potential for damage for that first earthquake than the second earthquake, even though it doesn't sound like it's only a 0.6 difference, but it really was 4 times stronger, okay, as far as shaking. And you can think about, okay, well, how much can I lift? Well, what about 4 times that amount? That's how much stronger that was. Okay, so than the other one. So that puts it into perspective that these little numbers in our difference in scale on the Richter scale, those numbers that they throw out, really have much bigger of a meaning than what we're used to. Okay, in 2016 there was quite a bit of earthquake activity going on, and we were following it, and so this question came straight from what was happening right about that time. April 26, 2016, a 5.1 magnitude earthquake hit Japan. You might have heard of that. There was a whole lot of damage that was happening, and those type of things. And then April 16th, just 10 days before that, there was a 7.8 earthquake that hit off the coast of Ecuador. Okay, so we want to ask how many more times intense was the earthquake that hit Ecuador. These numbers don't seem too far apart, but when we start doing the calculations, we're going to find something pretty surprising here unless you really have a good sense of what these numbers mean. So 7.8 minus 5.1 is our formula. So that gives us 2.7. So what this means is that 10 to the 2.7 power is how many times more strong that would be. And when you figure out how much 10 to the 2.7 power is, we get over 500 times stronger. So the one that hit Ecuador was 501 times stronger than the one that hit Japan. Now the thing is that was interesting at that time period, Japan is a lot more dense in population and things, so it would cause a lot more damage per se than it did in Ecuador, even though this one in Ecuador was 501 times more intense. And you have to look at how things are structured and how things are built. The Ecuador quake could have caused more devastating effects because the structures may or may not have been built to withstand that. So there's a whole bunch of things when there are different cities built on fault lines and they can expect the more intense earthquakes. They have to build things that are earthquake ready so they can handle the stronger amounts of shaking and the larger amounts of energy that get released during that time and possibly not cause devastating damage. So these earthquakes, if you're ever wondering, gee, I wonder how many more times that is, what you can do is you subtract the number and then take 10 to that power and figure out how much stronger one earthquake is than another. It's kind of an interesting thing to think about the next time you start hearing about earthquakes and think, gee, I wonder how strong that really is compared to how much shaking, how intense that other one would be. Okay, so that's about it for today. Please make sure that you're working on your assignment. We're going to work through our plan this week is to get ourselves to an open notes quiz by Thursday. We're allowed to network with people just to make sure that you're understanding all this. I do have a very specific goal for us to get to by the end of the year so that you are ready. And you guys, if you do exactly what I tell you, then you will be lacking really nothing getting ready for your next school year. All right, so that's it. And I wish you all the best. God bless you and have a great day.